Welcome to the Chapter 8.3 lesson video. Today we're going to be talking about the product and quotient theorem for complex numbers in polar form. All right, so that's kind of the key here, is that all of these are going to be in polar form. It's really just two quick theorems. We already know how to do this in rectangular form. That's a lot of what we talked about in the first lesson of this chapter. But today we're going to talk about how to multiply and divide these when they're in polar form, because it'd be a real pain to have to change them back to rectangular in order to do that. So let's go ahead and get started. So our goals for today is to be able to find the product of two complex numbers in polar form and to find the quotient. Product product does refer to multiplication, whereas quotient refers to division. So we're multiplying and dividing complex numbers that are in polar form. All right. So let's go ahead and start with the product theorem. So the product theorem goes like this, and it's actually kind of nice and convenient, and this is why we like polar form, is it's actually pretty easy to multiply numbers that are in polar form. If you remember in rectangular form, what you had to do is if you had x plus yi times x plus yi, you had to distribute x times x times yi times x, yi times yi. You had to worry about I squared. You had to worry about a bunch of things. In polar form, you don't have to do any of that. In polar form, all you have to do is you have to multiply the coefficients. So these are two polars, R1 CIS theta 1 and R2 CIS theta 2. You multiply the two coefficient numbers, R1 and R2, and then you add the two theta values, theta 1 plus theta 2. Now, I have this written in the expanded form. The other way you could write this is R1 CIS theta 1 times R2 CIS theta 2. And when I multiply these together, it's going to equal R1 times R2 CIS, and then in parentheses, theta 1 plus theta 2. All right, and that's probably the most simplified way you're going to be able to write that. You multiply the coefficients, the r's, and you add the thetas, the angles. And yeah, that's all that's to it. Let's go ahead and give it a try. All right, so here what we have is we have 3 CIS 45 times 2 CIS 135. So what I like to just kind of like rewrite this a little bit in the simplified form. So 3 CIS 45 degrees times 2 CIS 135 degrees. So the only thing that we really have to worry about is if when we add those angles together, if they go over 360 or if when we subtract them, they go negative, we're going to put them back to something coterminal. So we usually want our theta to be somewhere between 0 and 360. Usually the directions will tell you that. If possible, keep your theta between 0 and 360. So if it goes over, move it back, or if it goes under, add to get it back. But yeah, this is it. So we're going to go ahead and multiply the coefficients. So 3 times 2, we're going to multiply the 3 and the 2 together. And then we're going to add the thetas together, the 45 and the 135. So we end up with something that looks like this, 3 times 2 CIS, and then 45 plus 135 degrees. So we'll add those 2 degrees together. It's really not that hard, right? 3 times 2 is 6 CIS. 45 plus 135 is 180 degrees. So there we have it. Our answer is 6 CIS, 180 degrees. Depending on what the directions say, we could change that to rectangular. We could leave it in polar like this. It's up to the way the problem is described and what's presented to us. Let's go ahead and keep going. So product rule, we multiplied and added. So quotient rule, we're going to divide and subtract. All right, so quotient rule says if I'm dividing two polar numbers or two polar complex numbers, I'm going to divide their coefficients, R1 over R2, and I'm going to subtract their angles, theta 1 minus theta 2. All right, so it's kind of similar. So multiplication was addition, division is subtraction. This is a lot easier. You don't have to worry about having an I on bottom. A lot easier than in rectangular form. So if you can have them in polar form, that a lot of times will save you some headaches as you're doing these problems. All right, so here's our example problem. So I'm going to rewrite this once again in the kind of simplified form just to make my life a little easier. So I have 10 CIS negative 60 degrees, put that in parentheses, and then I have 5 CIS 150 degrees. And so what I'm going to do is I'm going to divide the coefficients. So 10 divided by 5 is 2. And then I'm going to subtract the degrees. So I'll do CIS negative 60 degrees minus 150 degrees. If I do that math real quick, I'm going to get negative 210 degrees. Now, I said earlier I don't like negative angles. A lot of times the directions will say no negative angles. So if you do 360 minus 210, you can change this to be 2 CIS positive 150 degrees. So I kind of added an extra step in there for us, but that is our final answer, 2 CIS 150. If you put 2 CIS negative 210, it's not necessarily wrong depending on what the directions say, but a lot of times they'll say keep theta between 0 and 360, so make sure you keep an eye out for that. All right, with that, you should be able to get started on the assignment. If you have any questions, please reach out to me. Otherwise, I'll see you in our next live session, and until then, I hope you have a great day.